Hi, my name is Dr. Kelly Korreck, and I am the program manager for the Solar Eclipse at NASA. I am so excited to be here today with you all to talk about the April 8th, 2024 total solar eclipse. So on the screen, you can see the image of the path of totality. So this eclipse is a solar eclipse where the sun is momentarily blocked by the moon. And along this path is where you will actually see that. And not just see that action, but then once the moon is completely covering the sun, you will see the sun's outer corona or atmosphere. And that's where our origins of space weather come from. So this is a really interesting and beautiful thing to behold. So in this path, there are 31.5 million people who live in that path, and around 200 million who live within a few hours drive of that path. And the entire continental United States, as well as parts of Alaska and Hawaii, will be seeing a partial eclipse. So that's about over 300 million people will experience a part of this celestial event. So it's a really neat opportunity to participate in NASA science and be able to view this safely, because we do want to make sure to view this safely. And Alex will talk a little bit more about the safety messaging. Next slide. And this is a image of what you might see in the path of totality. So again, the moon is completely blocking the sun, and you're seeing that outer atmosphere. You might see some striations or some rays that go out from the sun. That's the solar wind that is streaming away from the sun's things that we study to better understand our star, as well as then that space weather that can affect our daily lives that Jamie will talk more about. So with that, we'll move to Alex and safety.
Good morning. I'm Dr. Alex Lockwood. I am the Eclipse Engagement Lead on behalf of NASA. And yes, we have some really important messages that we need to convey to the public for this event. As Kelly mentioned, a huge population of the U.S. will actually just be able to walk outside and witness this. But in order to really appreciate the full event, we have provided over 2 million solar viewing glasses to across the country to members of the public. So these solar viewing glasses are ISO certified, and the number here is on the screen for what that certification is to make it safe to look directly at the sun with these viewers. Now, during the totality itself, which can last up to 4 minutes in different parts of the U.S., you don't need the glasses. We can actually look at the sun for the only time during the daytime, and you will see that beautiful coronal image that Kelly just shared. However, before and after, as the moon is eclipsing the sun, in order to witness this event and to see the spectacular Bailey's beads that happen just as you see the craters of the moon, right as the moon is fully covering the sun, in order to appreciate all of that phenomenon, you need these glasses. So we do want to warn that there have been some fakes that are out on the market that we witnessed previously and are currently witnessing on major online sellers. One of the best ways we've been asked is, how do you test these glasses? Well, if you hold up your cell phone camera, on the back there's a flashlight, and if you use these to look at the cell phone camera, you should only see a tiny point of light and absolutely nothing else. So that's a pretty good way to test these. You want to be very careful and only look at the sun with ISO certified safety glasses. If you do not have these viewing glasses, there's still plenty of ways to witness the partial or total solar eclipse. And that is using indirect viewing methods such as a pinhole projector. So there's plenty of resources on our website, science.nasa.gov/eclipses, on how to make your own pinhole projector at home. Very easy activity that you can create. It's an activity for kids as well. But your most basic instrument that you probably have if you've ever cooked pasta at home is a colander. You can take a colander from your kitchen, walk outside, and the projection through the colander holes onto the ground or whatever surface you have will be that of the sun, and you'll be able to witness a partial or total solar eclipse this way. So very easy at-home activities. to view the eclipse safely. Additionally, we have lots of other at-home activities that you can do for learners of all ages online. This QR code will point you straight to our website with all of those activities, including an activity with UV beads, which are very easy to purchase online, and inexpensive and respond to the UV light from the sun. So that's a fun activity for kids. We also have activities where you can draw what you think you'll see when that beautiful corona happens during totality, and several others. So we encourage you to go online. There's lots of very easy at-home activities for folks to do before, during, and after the eclipse. And for the eclipse itself, NASA has lots of events going on across the path of totality, which, so we have events all the way from Texas all the way up to Maine. We are sending lots of NASA personnel to give talks, to give out safety messaging, and to give out some of these glasses and other resources to make sure everyone has a safe but also enjoyable experience, because this is really an opportunity to be with your community and to witness an incredible phenomenon together. This is the last one in the U.S. for over 20 years, and it is happening just a few short months away. Finally, additionally, in addition to several major in-person events along the path of totality, NASA will also be doing a live broadcast from 1 to 4 p.m. Eastern on the day of the eclipse, where we will be showing views from Mexico, the U.S., of the telescope views of the totality as it passes over the U.S., and talking about the science that NASA does around the eclipses, how to view an eclipse safely, and how to continue to connect with NASA and NASA science well after this event has passed. So to talk more about NASA science and space weather in particular, Jamie.
Thank you, Alex. So good morning, everyone. My name is Jamie Favors. I'm the director of NASA's Space Weather Program in the Heliophysics Division. And rolling that beautiful solar footage in the background as we chat a little bit on the space weather side of the eclipse. I think that's kind of the really exciting part of this eclipse, as any eclipse is pretty exciting on its own. The fact that we're actually going to be very close to solar maximum for this solar eclipse adds a pretty interesting dynamic here. So we partner with NOAA, with the Space Weather Prediction Center. Very similar to terrestrial weather, Space Weather Prediction Center is the official source of the forecast when it comes to space weather alerts and warnings. Their most recent forecast for solar maximum is to occur actually this year, 2024, sometime between now, January, and October. So this is very likely right at the peak of solar maximum for this cycle that this eclipse will be happening. And as you kind of heard Kelly talking about, we're always observing the sun. Actually, as we look at the eclipse glasses, it's not so dissimilar to the way we think about some of our really sophisticated instruments in space and here on Earth, about using filters to be able to observe the sun in different ways to protect those sensitive instruments, but be able to really peer in and understand the way the sun works to be able to answer those questions about space weather. So if we're lucky, we may actually be having space weather events occurring, solar flares or CMEs, right around the time of that eclipse, and that causing that corona, as Kelly was talking about, to not just be pretty static looking, just with normal solar wind, but we may actually see the fingerprints of a recent solar eruption actually in that corona, actually see very dynamic structures in that outer, the corona features out there for the atmosphere of the sun as it really first starts to move into interplanetary space. So that's the part I'm really excited about, to kind of wait as we start leading up closer and closer to that day to kind of see, hey, is the sun going to give us something exciting to see, both from space weather perspective, but just for a curiosity's sake to be able to see those features out there. So I think that kind of tells the story on the space weather side. I think it's personally here too, I'm a meteorologist and atmospheric scientist by background, have a lot of friends that went into the broadcast meteorology field, and I'm really excited for that day where we're also talking about space weather as we talk about weather on the local forecast at night, and talking about those impacts as we think about them here on Earth. There's a lot of ways where the sun actually touches and influences our lives in ways we don't often think about, whether it's the signals we have from GPS signals coming through the atmosphere, the way we use radio propagation, impacts on satellites and spacecraft in space, just to everyday life, the way even animals migrate depend on things that can be impacted by space weather. So I think we realize maybe less than is actual true about how often the sun and those features that are 94 million miles away from us actually come and touch our lives every single day. So.
All right, thanks very much. We will now open it up for Q&A. So for people in the room, if you can just head to the mic and please state your name and your affiliation, and if you're directing your question to a specific person. And then just a reminder for everyone that we are recording and we'll post this online later. All right,
Morning.
go ahead.
Hi, Todd Glickman, WCBS Radio, New York City. Will NASA or NOAA be making cloud cover forecasts within a few days of the event to help steer the public to the right places along the path?
Oh, so those forecasts do come out regularly. So I mean, those sources will be out there. I don't know if we're doing anything special to connect them to anything on the NASA side, but
Nope, NOAA is responsible for NOAA is responsible for the weather.
yeah. But I suspect it'd be the same products that are always available. But
Yeah, hopefully they'll do a path-specific public information statement within a couple of days.
that's a good idea. That's great.
Hey, y'all, thanks for the talk. I'm Ben Cathy from WVLT in Knoxville, and we're on the east side of the state, so we'll only be in a partial eclipse, but there's a tiny, tiny, tiny sliver of northwest Tennessee in the path of totality. What is the difference going to be in your time under totality from kind of like the centroid of the path versus the edge of totality?
There is a difference. So the center of the path is where you're going to get the maximum length. On towards the edge is when it's going to be more like seconds. So the center is going to be 4.5 minutes. The sides are going to be 20 to 30 seconds. So if you can go a little further in, it is into the center line. That's where you're going to get maximum totality. But even for a brief second, the experience is well worth it.
All right, while we wait and see if there are any other questions in the room, one that I have is, I would love for someone to tell us a little bit more about some of the NASA science experiments that are going on during the eclipse.
Great question. We are using the eclipse in many different ways. First of all, to look at our star, the sun. So we have one WB-57 airplane with 2 experiments on board that will look at the solar corona as well as and study that outflow, as well as look for some of the dust that's around our star. And you might think dust is boring, but it's not. It's actually the remnants of how the star was made. So that's why it's interesting to understand the process of how the planetary formation and the stellar formation. So a little information about dust as well. Then we will be using ground-based assets, so things like radio arrays, to look at the star, our sun, and take those really active regions that we see at the solar maximum, and as the moon perfectly covers them and goes across the disk, they'll take different signals to actually be able to see in height what is going on. A neat technique there. And then we will be using this eclipse to test our atmosphere. So our atmosphere has this charged layer that we use that bounce communication signals to. And so we have folks, the ham sci, who are using ham radios to do this test. We are also doing other tests through actually a series of 3 rockets launched from Wallops. And there will be one before, during, and after the eclipse to study again that ionosphere and that collapse that it happens when we have that sudden day-night switch. So those are some of them. There's also citizen science projects. Does anyone want to take citizen science? I can keep going. These are very, very exciting. So we also have citizen science projects from the Globe Observer app, where folks can download an app and help take observations of the temperature and what they're seeing during an eclipse and what they're experiencing. There's eclipse soundscapes, which is listening to the eclipse, and this is the sounds that happen because animals do think it's nighttime. So there are different things that happen and that you hear during the day, and then during the day to night transition during the eclipse, and then back to day. So that's being recorded and sonified. And I think that's any of the other ones that I'm forgetting right now. Ham sci, and the eclipse, Eclipse Soundscape and Globe Observer. There we go.
Thank you. All right. Oh, okay.
I had a few more questions, if I can just rattle them off. For the glasses from the last eclipse, I've been told there's like an expiration. What's the danger in using an older pair of Eclipse glasses from a few years ago? And how widespread of an issue are eye problems after? Do you guys have any kind of data on that?
So in terms of the glasses certification, what I would do with your glasses is test them. Even if you have a brand new pair, I would test them internally, as we were talking about with the cell phone, that you should only see a pinpoint from that flashlight after you use them. So if they are not damaged and you have tested them indoors without looking at the sun, that was telling us that they should be relatively safe to view the sun. In terms of the widespread damage, we did a lot of, or widespread damage, the fact that there wasn't any was because we get the safety message out, and folks are very good about actually understanding that they need either a pair of glasses or an indirect viewing method. There's actually a lot of fun ways. You can even use your hair to do these pinhole projections. You can use your fingers to, you put your back to the sun and put your fingers out to the side and pinhole project. So I think there's a lot of interesting ways. So we have not seen many cases of solar retinopathy, and I'd have to go to the opticians to see how many cases, but there's not widespread reports.
I think being partners with the broadcast community and like sharing these messages is part of why we haven't seen some of those issues too, right? It's all of us sharing that good message out there about the cool parts of the eclipse, but also staying safe. So.
Thanks. Last eclipse, I did a piece with the blind community about how they experience the eclipse, because it's such a collective time for people and they're kind of left out. I know NASA had an app which was vibration based. Are there any other new tools for underserved communities at this time?
Yeah, that's a great question. So we do have some teams who are, some of our student teams have created, as they take measurements, they've created a tactile version of recording those measurements. And so we're working in Indiana. There's a student team there who's working with the Indiana Association for the Blind, or I'm sorry, I'm getting the acronym messed up. But we're making connections there with actual science experiments. We also have tactile books that talk about eclipses and the path of the eclipse that we're passing out at all of our NASA locations. And the Eclipse Soundscapes project is really one of those unique opportunities where we are encouraging folks to close their eyes for at least a few seconds, if not longer, and witness how other communities will experience this event, which is actually pretty incredible. You feel the temperature change, you hear the sounds, and the atmosphere and the animals respond. We have put as much thought. We've put a lot of thought into how do we share this with others, because it's a communal time. And that is for everyone. The sun touches everything and affects everyone's lives, and that's what we are celebrating here, not just folks with sight. So.
Yeah, just one more. Sorry, I'm like the annoying guy on the sports radio show. What do you think as far as hotels being booked up already, or do you think it'll be closer to the event when we get a better idea on the forecast?
From our current experience, there are definitely locales where hotels are already sold out. And then there are some locales where you could find a hotel room or two. So I would advise making your plans a little bit earlier than you might usually, although we all know that eclipse chasers will probably make multiple so that they can change based on the weather.
All right, I know we've talked a little bit about the weather and how that can affect the experience. But I guess I would like to hear a little bit more about other factors that people might want to consider as they're making plans. For example, the NASA events that are going on. What should people be taking into consideration?
Yeah, and in addition to the hotels, there are several major cities along the path who have been planning for years to celebrate this incredible event and to accommodate the large crowds. Those include Rochester, Niagara Falls, Buffalo, all in New York, Erie, Pennsylvania, Cleveland, Ohio, Toledo, Ohio, Indianapolis, Indiana, and Dallas, Texas, definitely Dallas and Waco and Austin, all, that's just a few of the major cities that are along this path. So the different cities are taking different preparation measures. For example, the city of Austin is very much encouraging folks to stay where they are and not gather centrally. So for locals, just to kind of, shelter in place, as it were, understanding that there will be a large influx of other people. But in terms of emergency management, crowds, traffic management, all of these cities are taking this very seriously. You can find lots of information both on individual city websites, but also at science.nasa.gov/eclipses/events. So NASA has partnered with several of these cities to not only bring a NASA presence, but ensure that we are we are ensuring people's safety, both eye safety with glasses, but also physical safety, and mental well-being to make sure that there are facilities for everyone. Currently we have 12 cities that NASA is partnering with along the path of totality. But we will be sending speakers to dozens more locations, both on and off the path of totality, because, as was mentioned, everywhere in the contiguous U.S. will experience a partial eclipse, which is still a very rare and cool phenomenon.
And I would also say you can choose your own adventure here. So if you really love parks and the outdoors, you can see the eclipse at a national park or a local park. If you are more of a city dweller, just make sure that you can see it over the building that you've chosen to put yourself near. But that might be exciting, or a football field, a stadium or something like that. That might be a good choice. So part of it is designing the whole experience that you want to have. Choosing the city or state or park along the path that you'd like to actually celebrate in.
Great. And talking about how people can participate in the eclipse, I know we talked about some of the citizen science projects, and I think that can seem a little bit intimidating to people, but can you talk about some of the projects that people can really just go out in their backyard, pick up their phone and do?
Okay. No, I'll talk about it. So, for instance, the Globe Observer app, again, is something that you can simply download, and we are encouraging folks to maybe even prep ahead of time, because you can also record cloud cover or do other activities with this. So it's an app that's downloadable. Folks can register, and then you simply go outside in your backyard and make observations and type it or press buttons in your phone, record things with your phone. So this is a relatively easy way to participate in science and really get a feel for what we do in terms of data collection.
Great. All right, Jamie, I know you talked a little bit about how we can see the corona and some of those sources of space weather during the eclipse. And can you talk a little bit more about the other ways that we look at space weather, how we're gathering that data, and what our scientists do with it?
Sure. So this, as a kid, I kind of always thought of our star, the sun, it's a pretty static feature and just like one color, even though I wasn't looking at it, I promise. And I realized, especially getting later in life and starting to kind of understand, especially with more sophisticated, instrumentation that we can put in space and here on the Earth, we can measure in lots of different wavelengths, looking at different temperature profiles, energy profiles in the star, and be able to really kind of dive in a little bit deeper, not just seeing one actual surface of the star, but actually dive in and really understand multiple interactions that are going on there. So if you saw some of that video earlier and you saw the different colors that we're showing, that's actually what we're looking at. We're actually using different energy levels to look in different ways at the sun. On the NASA side, we get to answer really interesting science questions about that. That's really what drives so much of the work we do, is that understanding of what is truly going on in our star, because there's still so much of it that we don't understand. The end goal for us really is getting to the point where we understand it well enough to be able to predict it. and hopefully be able to predict it out in time quite a while. And that's really where the partnership with organizations like NOAA, where they're really responsible for that forecasting, becomes pretty critical for us. So that's that endpoint, and then transition that science understanding into like real world applications for them to take that next step on the forecasting side. There's so many similarities here with terrestrial weather here on the Earth, about maybe where we were 30, 40 years ago with being able to, forecast out, a hurricane event. Now, we're 5-7 days out and sometimes have very, very reliable forecasts. That's not where we were, 30, 40 years ago. But that's similar, where we are today for space weather. It's kind of where we were quite a few decades ago. And imagine, for some of these most high energy events on the sun, that's all reaching us here in about 8 minutes. Imagine if your hurricane forecast gave you 8 minutes of warning on what was going on. I mean, that's kind of what we're talking about, right? Not only here for Earth, but also as we send astronauts deeper into space. We started with Artemis 1. With Artemis 2, we actually have crew on board going back to the moon. And as we think about sending astronauts to Mars, this becomes ever increasing bigger challenges, not only being able to make these measurements, analyze those data, to be able to give that forecast that people can make decisions with the science information all the way into just what we do here in terrestrial weather, knowing, oh, hey, do I want to take an umbrella with me today? It's almost the same kind of thoughts when we get to that understanding on space weather.
Thank you. Any other questions in the room? All right, I'll do my last one. I know we've talked about how people can view in person, but if you're not close to the path of totality or have bad weather, does someone want to talk a little bit about the NASA live broadcast?
Absolutely. So we're very excited to be able to live stream views from over a dozen places along the path of totality, starting in Mazatlan, Mexico, excuse me, going through Texas, up through 15 different states, and coming out the other side of the U.S., out of Holton, Maine. So we will be doing a live broadcast starting about an hour before the first contact in Mazatlan, and continuing for 3 hours so that we cover the entirety as the eclipse passes over the U.S. We will have live solar streams from different telescopes, including solar filters, and also solar filters and different types of H-alpha filters. And we'll be talking about, we'll have watch parties from different locations, both on and off the paths of totality, to really understand what people are experiencing, because we want to bring this event to folks who are not able to witness it in person, both the visuals but also the sentiments, because even if you're not experiencing it, the total solar eclipse, you can experience the partial solar eclipse, and you can take a moment to appreciate what the sun does for our everyday lives. And so we're really leaning into that on our broadcast, because many folks don't know that NASA studies the sun, and they don't know all of the important effects of space weather and the sun on our everyday lives. So bringing that awareness and the importance of the work that NOAA and NASA do, and the work we do together, as long as all of the science that we can understand about our everyday lives, both the Earth and studying Earth and the sun during this phenomenon. So we had over 50 million views in 2017 of our live broadcast, and we expect similar, if not greater, numbers this time. This eclipse is passing over about 3 times as many people in person. So the opportunities for in-person engagement and for people to witness it themselves is incredible, including a lot of communities that may not be as in tune with science or as interested in what's going on around them. But we hope that the live broadcast both brings the opportunity to others and also is able to kind of last as a moment in time for what NASA and the U.S. is experiencing and celebrating.